In this session, I will be talking and demonstrating my new software creation. It's called, as you obviously know, uberAgent. It's an add-on to Splunk. And it probably should start by just saying a few words about what Splunk is, so that you know where uberAgent fits in, what it actually does, and what it does not do, and what Splunk already provides. So Brandon has been talking about Splunk a little bit yesterday and already this morning, but there weren't so many people present in this morning's session, so I guess most of you, not everybody here, probably had a good overview of what Splunk is and what Splunk does. Splunk is not a monitoring product. Splunk is a data processing platform, or tool, or whatever you want to call it. It's inherently scalable. Many of you have probably heard of this term, big data. This is really hip. And it means processing huge amounts of data and mining, searching and mining for the odd nugget that is hidden in each. If you sift through enough earth, there will be some gold eventually. But it just takes some time. And the same applies to data in some way. Organizations have accumulate and generate huge amounts of data, of machine-generated data all the time. Each server that runs it's a Windows server, has several event logs. And in those event logs alone, so everybody of you has looked at them. There's so much stuff in there. Some of it is extremely valuable, at least in certain situations where you want to troubleshoot and find the cause of some issue you are looking at. But most of it is just idle chatter. And the difficult thing now is finding the interesting bits and ignoring the rest. Now, if you think about all the data that is generated by all the servers and PCs in your corporation, only log data. Each product, each service probably logs some messages somewhere in some event log, some log file, wherever. If you accumulate all that, it's a huge amount, a huge quantity of data. And you need a very efficient system to handle that data. And Splunk is such a system. And you can set up Splunk really easily, really quickly. If you have instructions on my website that if you follow them, you'll probably be up and running with Splunk in, let's say, 25 minutes, and then if you set up uberAgent after that, you'll be done in less than an hour, and you have an environment that gives you really great insights and tells you what's going on in your machines. So getting up and running is easy. It takes a little bit more to really dig what Splunk does, and if you want to use it to its full potential, you will need a little bit more work, but it can start with 1 hour. So and it's 2 hours, 1 hour for this presentation and the second hour for setting it up. I'll just show you a little bit. Please ask if there's anything that's not clear. Just ask me. I'll be happy to explain. So what you need is one thing, obviously, is Splunk server, which is kind of the data repository that stores all the data, indexes it, and acts as a search head. So you direct searches at it. It's a little bit like Google. Maybe I should start with that.
Question.
Yes.
Splunk cloud service.
Yes, Splunk has, probably not everybody knows it, Splunk has two versions, kind of, two editions. The traditional edition, which you install in your data center on your server, that runs on various kinds of operating systems. And the other thing is pretty new, it's called Splunk Storm, it runs in the cloud. It's more or less the same. It's Splunk Storm. The cloud variant is ideal for data that is created in the cloud by cloud web services or web server data. So it makes sense to direct the data from one cloud to another and to process it there. I don't actually know if uberAgent would run with Splunk Storm.
So I can answer that question. It will send data to. It will send. uberAgent can send to Splunk Storm, but you cannot do, at least right now, you cannot do dashboards in the app. Like you can't use the uberAgent visualizations that he's made on Splunk Storm. It's something they want to add. It's not there yet. So, but there's nothing to stop you. Like if you really want to have an Amazon instance, there's nothing to stop you from installing Enterprise Splunk in Amazon.
Thank you.
Yep.
Okay, when you've installed Splunk, you first get a search box, a little bit like Google, as I just said, and you can start by typing some magic characters. Let's start with this, and it'll just take a few seconds, and then it'll display things like this. You see, there are multiple events shown here. The events are numbered. There's number 1, there's number 2, 3, and so on. And each of these events has one or several lines of text, of data associated with it. Each event has a timestamp when it was generated. In case of multi-column events, it's a bit like a CSV file. You have headers, process ID, process type, URL, and then you have the actual data. And that's a multi-line event, and here's a single-line event. You have, again, a timestamp, and in this case, the actual data, which is session count, is 4. So apparently there are 4 sessions on this machine called TS3. So that's the raw interface Splunk brings. You don't work with that. I was just showing you showing this to you so you know what the value of the dashboard, the dashboards that are actually provided. So, but in order to get this data, you need some tool that gives you all this data and gets it into Splunk, and that's about 80% of what, 90% of what uberAgent is. It's an agent, meaning a Windows executable, actually a single executable that has no dependencies at all. It's written in C++. It runs on any Windows system newer than Vista or Server 2008. If you want to, you can just copy it to any Windows machine anywhere and just start it, and it will start to collect data. Of course, it doesn't. It makes more sense to use it in conjunction with Splunk's universal forwarder, which is kind of a generic agent which developed by Splunk, which can collect data from log files or from other programs. And uberAgent is one such program that gathers data and forwards them via Splunk's universal forwarder service to the big Splunk pool of data. And so if you use uberAgent, you have one instance of Splunk's universal forwarder on each machine you want to monitor. And on each forwarder machine, you have this single Windows executable called uberagent.exe. And once you have that, you get all this great data. One of it. That's perfect. It's a little thing missing. Most Windows administrators are quite fond of. That's the graphical user interface. Because of that, uberAgent actually is not everything. It's only about 90%. The other 10% are the dashboards that come with uberAgent. And when you access the start page of this dashboard, you get a view like this. I'm sorry, the resolution of that screen is not really, of that projector is not really tremendous. I just make it a little bit smaller, you can get an overview. This is just an overview page. I thought it might be nice to have, to get an idea about what is happening in a ZenApp or Zelisto farm. So here you see one column for each server in your environment, or for each machine actually. It doesn't matter if it's a server or a client. Here you see the logon times over time. And this is for the last 24 hours. It's difficult to see. I probably should magnify it again. Okay. So over the last 24 hours, we have had a few logons here, and you see exactly when my laptop was turned on and when it was not. And when it was turned on, during these periods, you have logons. Some are slower than others. And some are faster, obviously. You can hover with a mouse on one of those columns, and you'll see exactly what the time was. In this case, 24 seconds, and when that happened. So with this, you have an overview. If the logon times are good, and if the number of sessions, in this case 25 sessions, that's the peak here. If the right number of sessions in your environment, and users are able to log on at a good speed, then probably your environment is more or less okay. There can't be really a lot wrong with it. Okay, but that's only the overview page. Let's see what we can find out. Let's look at the second one, user sessions. Now, on my dashboards, they have this time selection thing, which you saw earlier. When you click on it, you can choose some predefined values. For example, the last 15 minutes, you can choose I want data from the last 30 days, whatever. You can define a custom time that lets you define in a really granular way exactly from which point in time or for which interval you want to see what's going on. And you can always filter. So you see a lot of data here, many information from many user sessions. Maybe I want only the information for a specific user, let's say test 5. So I just entered that filter box, and it limits the data that is displayed to that. So I see a user session on server PS1. The guy logged on at this point in time. The connection is via RDP. The guy has 14 processes that he's running, and you can see what resources that session is consuming. Now, isn't that interesting? These are the resources per session. If I'm not mistaken, well, at least I think most monitoring products, they don't give you data per session. They give you data per process or per machine, but the concept of having a session as an entity is rather unusual, at least that's what I think. Now, let's delete that filter again, so that these graphs at the bottom make sense. And it shows you here which users, or more correctly, which user sessions are the top CPU, the top resource box. So which user uses is most CPU intensive, which is worst for I/O, which user uses the most amount of RAM. And I also have, in addition to that synthetic data I have in...
you seem to be very busy.
Yes, indeed, I am in there. I also have the data from a laptop, and that is live, real, unfiltered data. So my laptop is called HKT552, so it's that second one over here. So yes, that user does use by far the largest amount of RAM. So my session basically uses 1 gig of RAM. That's not that much, but for a laptop. So this gives me an overview of all these sessions I have. If I want to know more, for example, this Helge guy. So what exactly is going on in his session? I just click on the session and I get a really detailed overview of the various resource usage over time. So what the CPU usage was, RAM, IOPS. So there was a slight peak. 80 IOPS here, let have an SSD at IO volume. And of course, I can change that to a different interval in time. And you can see exactly when my laptop was turned on again. It was running. Might be interesting to find out the IOPS peak. This might take a little to run, but not too long. Oh, this doesn't work. Interesting. Okay, thanks. We just found a bug. Ah, no, it's slow. It's slow. Is it possible that it's...
Well, it functions on a desktop, but yeah. How many IOPS does that thing generate?
Question.
I bet you're going to spike it right now.
Yes, probably, yeah. So, okay, this might take a little bit too long for this demonstration, so let's switch back. Okay. Okay, these are user sessions. In the same way that you can get data about user sessions, you can get data about session 0. Session 0 is everything that Windows does. It's what the kernel does and all the drivers, and more importantly, all the services. So if you want to know what your machines are doing, but not the machines with all your users, but only the operating system, what kind of overhead you have, because the machines themselves you don't run Windows for Windows, but because you want to run Windows. You run Windows because you want applications, because you want your users to use applications. So Windows is more or less overhead. Here you can see how big this overhead is, what kind of CPU usage you have, memory usage, and all that kind of stuff. And again, which system is the biggest consumer, and so on. Now, that's all really nice, but one of the most interesting things, especially with regards to XANAPP, is logon times. Everybody has logon times that are too long. Many people have logon times that are way too long. So, that's a topic that is well known, but it's really hard to troubleshoot that and to get to the root cause and to know, okay, what is my actual problem? Why do I have bad logon times? So uberAgent really helps you a lot with that. It gives you, in this dashboard, each single logon, a little bit similar to the previous one, but then I'll try to make it easier to read for you. Okay. It tells you for each logon what was the total duration, and then how, if you split that into its individual phases, which phase of the logon takes how long. So, in this case, the loading of the user profile, that was really fast. So, that was not because that really didn't contribute much to those 13 seconds. But group processing is already a little bit more, nearly 4.5 seconds. And this user has an AD logon script configured that took more than 3 seconds. The user also has a group policy logon script configured, which also took 2 seconds. And it took an additional 4.5 seconds for the shell, meaning Explorer, to start up and show the desktop. So you get this really, really detailed data for each single session, and you can see this graph, if you have individual users that may have a lot longer logon time or worse logon time than others. In some cases, you may have users with a large profile. So you might have one user with a really, really bad logon time and all others with a good logon time. Then you can focus on that guy and try to check out what's wrong with this person or this profile or whatever. Or you might have a server that has some problem and delays logons for whatever reason. So by comparing and showing all the servers next to each other, you can see pretty quickly if all of your machines are affected or if a single machine has some misconfiguration. For all this data, for every table I have, you can always get explanation if you want to know what the data that is displayed exactly is. So you don't have to guess like with EdgeSite or so. Now I said the word. But that's not all. You see here, group policy is one blob. What do you do if you have a long time, if group policy processing takes a long time? You need to know what the problem with group policy actually is. There's a second dashboard that displays that. And it shows you here the total time it took to process group policy. And then it splits that total time into individual phases. Now, first, communication with Active Directory is labeled PC Discovery here. If you have some kind of DNS problem or other AE-related problem, but in most cases those are DNS problems, then you may run into timing problems or timeout issues, and this value will show you that. Next, depending on the number of policies you have configured, different client-side extensions on the client, or the client processing the policies, will be invoked. And for example, if you use group policy preferences to set an environment variable, the client-side extension, sorry, I changed the sort order now, but that doesn't really matter. The client-side extension group policy environment will be invoked to process that setting and make it happen. Now, uberAgent tells you for each client-side extension that exists on this planet how long it takes to process. There's no finite list of client-side extensions. Microsoft alone has a list that's good 1 or 2 pages long, and every vendor that extends group policy, like Citrix for example, can add their own extension. And uberAgent will show more. So, so in this case, there was not too much happening, like some drive mapping, not a likely candidate for timeouts or network-related problems. A little bit of Internet Explorer branding, and
Internet Explorer.
Okay, so as you can see, you get really detailed information about what happens at logon, and this should help you really pinpoint the actual problems you may be having. And again, it shows you these times per user and per server, so you can see quickly if there's a problem with an individual user or machine. Okay.
I have a question.
Of course.
Is it possible to get group policy that actually, could you break it down by actual group policy? I don't know if that information is available.
Not with the data right now, no.
But I mean, is that something we could add?
Potentially. Okay, that's the session-related data. Again, you get performance per session and really detailed logon times. Next, another entity you have in Windows or in any computer system actually is an application. And an application is not a process. The process is an executable that runs, but an application typically is comprised of several processes. If you have Microsoft Office, of course, there are many executables on disk, and many of them may be executing simultaneously, or even something like Adobe Reader consists of several executables. There's the updater, there's the actual reader, there's some speed launcher, or something that gets auto-started. And uberAgent knows about application. It has a notion of applications. So it doesn't only show you, if you want it to, it can show you the data about processes too, if you're into that. But it has a notion of applications that it can show you, okay, I know there's an application called Microsoft Office, blah, 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 and this application consumes so and so much CPU time or memory or whatever. And uberAgent auto groups processes to applications. So you don't have to configure which processes make up Microsoft Office. It determines that automatically. And it can show you, of course, too, which applications consume the most resources. So the screen resolution is a little bit too bad, so that if Splunk has a really neat feature, I should show that, I should demonstrate that. I reset the zoom level to default. This Splunk UI is pretty cool. It's what you call in a web UI fluid. So it auto-adapts to the available screen space. So we take this window and resize it. Let me try to do that. You'll see that the graphs move with the window. They get smaller. So, and as they get smaller, when the full text cannot be displayed anymore, Splunk uses ellipses, which are the programmer's term for these three dots, to abbreviate. When you make it larger again, it uses the space as best as it can, and displays more of those words. So just to give you a little example of that and explain why those names are abbreviated. Okay, so you can see, back to the applications, which applications I have here and what kind of resources they consume. Now, as before, you can drill down on an individual application and check what it's actually doing. Let's take a look at uberAgent. uberAgent monitors every application, so it also monitors itself. Why would it not? It would have had to exclude it explicitly, but that would be like a little bit like cheating. I tell you performance data for everything, but not about myself. No. I'm big and fat and ugly, but I'm not going to tell you. No, uberAgent is quite the contrary. It's lean and sexy. It really is. Look at this.
Are you saying fat people can't be sexy?
Sorry. Just doing some politically incorrect jokes.
They are sexy in such a t-shirt.
Yes, that's it. Thank you.
Buy them.
Yes, I think one can have one if you want to. Well, the thing is, uberAgent is really lean. Let's leave sexy out of the way. Lean and lean.
Stop digging, move on.
Sorry?
Stop digging, move on. Stop digging a hole. You've got in a hole, leave the hole, carry on with the conversation.
Oh, yes. Okay. You can see that the CPU usage is well below 1%, so it's really not noticeable. RAM usage here, that's the average of 5 machines, is roughly 13 megabytes. I/O volume, and I'll come to IOPS in a minute. I/O volume is next to 0, it's 0.001, and IOPS are not really much, in the range of 2.5, and that is only because I've turned on debug logging for uberAgent. So basically, uberAgent can write a really, really detailed log that if you have a problem with uberAgent, it will be the cause, the reasons for that will be in the log. And I've turned debug logging on, so it writes a lot of data to disk. And if you don't want that, you can turn debug logging off, and those apps will be gone. So compared to EdgeSide and probably a few other monitoring products, the footprint on the system is...
Yeah, I just want to say, this is, I wouldn't just kind of breeze over the fact that you're actually able to get IOPS for a process. Because most applications, minor applications, don't do that because there is no performance counter to give you that value.
Yeah.
Performance counter gives you total I/O, but it doesn't actually tell you disk IOPS. Because he's where he sits on the machine, he's actually able to tell you the disk I/O a process can give you.
That's actually a very good point. Some monitoring products rely on...
See, that is sexy.
That's always sexy.
There are monitoring products that tell you they're agentless, and agentless stinks. Because agentless means you don't have code running on each individual system, meaning you can only get to the data that's available via remote procedures, like remote calls, like WMI. You don't want that. for several reasons. WMI is horrible. It's really, really resource hungry, and it gives you only so much data.
And you can't scale.
Yes, can't scale, right? So if you want to have an efficient monitoring, you need really efficient, well-written code, but on each individual machine. And as you see in these graphs, that can be really, really small, small executable. Okay, let's go back to the applications. So you get all that performance data per application, as we saw, and when highlighted, of course, I/O data too, CPU data, and RAM usage. But if you have all that nice information available about applications, it's only logical to go a step further and calculate application usage. That's something that's really, really helpful for at least for these two things, for license, for compliance, actually, in other words, tracking the number of copies of licenses you need, and for sizing. Really knowing what's actually being used in your environment is something that few admins have the privilege of. So if you have terminal servers or fat clients, you'll probably have a few thousand applications out there and know nothing about them. uberAgent shows you what they are, how often they are used, and if you want to, on the previous dashboard, what kind of resources they need to run. So in this case, I have, the read is free, so that doesn't really count, but Microsoft Office Professional Plus 2010, 20 instances. So that's the amount, the number of licenses I should be getting, or should be having rather. And of course, you can display it graphically too. So whatever reader is the application used most heavily, and then it's going down from there. One other thing, if you have application usage, you might be concerned about how often are these, what's the usage over time. So it could be that I have an application that's only used once a month for some bookkeeping, accounting things that are not required daily. So you click on an application, let's use Office again, not again, let's use Office this time, and it shows you how many instances of Office were running at this exact point in time. And with that, if you have uberAgent deployed and let it gather data, if you want to size your environment, you can see exactly, okay, the highest number was, for example, let's say, when the last quarter ended, when the financial stuff had to be calculated, and then you know exactly for what numbers you need to size your environment. Okay, another thing that's related to applications is, well, your browser. The browser used to be just another application, nothing special. But that changed a few years ago when web apps became fashionable. And when a browser runs web apps, possibly multiple ones concurrently in several tabs, the browser is more than just an application, it's a runtime environment. So it's something like an OS, the operating system for those web apps. And if you see that your browser uses up a lot of resources, you might want to know why. Which websites generate that load? uberAgent tells you. Let's take a look. So you can see per website, for example, I have highlighted Yahoo, the amount of CPU time they consume on your machines, or the number of I/O per website, or the amount of RAM they need. And of course, you can display that graphically. These graphs are just Splunk doing formatting the data in a different way, so that's basically the same internally. And you can see that the top website, the website that steals most of your CPU time, in this case, in this example, was Yahoo. Why? I found during the test that I did for this that Flash ads are really, really bad. Not only Flash ads, but also HTML5 ads, all these fancy stuff with JavaScript. It can really, really eat a lot of CPU time. But that's another topic. Why these websites need that performance? The great thing is that uberAgent shows you what's going on. If your research usage is high, it might be a new ERP site that you've have enabled for your users, or it might be a user just watching YouTube. Might be interesting to know. And of course, this is also available over time, as is more or less all data. So you can see which website is hit most or generates most load. So you can see during the lunch break, potentially, YouTube usage goes up. If YouTube usage is high during the day, you might have another problem.
Like during your session, YouTube is up.
Sir?
Like during your session, YouTube is up.
Yes. Okay. Now, of course, uberAgent gives you traditional data too. So it gives you data per process. You probably know what to expect. Why does it take so long? Okay. So it's more or less the same we saw before, but this time per process. So I can, if I want to take a look at what uberAgent actually exactly consumes. And of course, I have some graphs for that too. So you can, accurate reader is the worst CPU thief. CPU is second thief, whatever. Internet Explorer is second, interestingly. And of course, we have data per machine. That would be one virtual or physical Windows box. And the data is pretty detailed, but it's more or less the standard stuff you get within Task Manager too. A little bit more interesting is probably this disk I/O. When Jim is leaving, just when it gets interesting for him. This disk I/O dashboard.
His girlfriend over, so
Okay. So, but
His girlfriend is slightly more attractive than IOPS.
but not only slightly, I would say.
and you can quote him on that if you want me to go.
But sorry, Eddie, we're not yet used to the fact that you're in the same world as
There's no tweeting that.
No, I'll keep that one for later.
So this gives you extremely detailed I/O data per machine, and also again the top consumers in various categories. One thing that is way underestimated is latency, because latency more or less defines how long does a user have to wait for something to happen, for a window to pop open or whatever. And so latency is basically the thing that should always be zero and probably never is. And you really want to optimize for that.
What is latency of what exactly?
That's the amount of time an I/O request takes to complete.
Oh.
So the simplest thing would be me saving a file in, let's say, in Word, and Word tries to store that file, of course, issues an I/O request,
right.
And it takes some time until the disk has actually acknowledged that it is.
So you're saying your laptop doesn't have an SSD?
It's interesting why the data is so. Why these values are so high for my laptop. I haven't noticed that before. I'm pretty happy with the performance, and I have two SSDs actually made, and no traditional hard disk. Let's take a look. Okay, nothing extraordinary here. The latency. Okay, that was probably when I switched. Yes, came out of Hibernate or Suspend for everything for the values to initialize. The first value is obviously a little bit bogus. Okay, nice. One thing that should be interesting to every XenApp and XenApp administrator is the ratio of I/O writes to I/O reads. There's been quite some discussion albeit a few years back, when people used to think that in a steady state, meaning when the operating system is booted up and the user is logged on, that most of the I/O would be reads. And that's not the case. Ruben Sprout has published a paper about that a few years ago, and his measurements indicate that it's the other way around. So roughly 80% writes and 20% reads. And you can see in my case, it's a lot more interestingly. It's 95 to 97% writes. So, yeah, that should be quite helpful. Now I see we started at a quarter to 5 and have about 4 minutes left. One thing that's important is, of course, how is money? Splunk is licensed by indexed data volume, so it is really important how much data uberAgent generates. If you want it to generate as few data, as few megabytes per day as possible. I've put great consideration on this specific aspect of things, and I've also added a dashboard that tells you exactly the amount of data that uberAgent generates. It collects and forwards to Splunk. So in several categories, and it shows you exactly how much is in each category. uberAgent is configured, can be configured in great detail. You can switch on and off a lot of things. And if you're not interested in some specific detail, and you find that it generates a lot of data, you can just turn that off. You can also change the frequency at which uberAgent collects data. By default, that's every 30 seconds. You can change that. You can increase it, but that would increase data volume. But you can also decrease it. If you find that, for example, every 60 seconds is fine in your environment, you just change one value, and you have roughly halved your total data volume per day. Okay. The dashboards uberAgent comes with, they're more or less examples. They are what I and a few other guys think that is sensible, is useful and sensible, but you can pretty easily adapt them and change them and create new ones if you want to. I'll just give you a very, very quick overview. Dashboards are created in this kind of XML dialect, and while at first it may look a little intimidating, it is really pretty simple. I have created, all in all, until now, let's see 24 different dashboards, and the first one was hard. That took me quite some time. You have to learn Splunk, and there is some learning curve. You can't really. I would be lying if I said that wasn't the case. But if you have done your first dashboard, the second is basically a copy of the first to 80%. So this thing has a certain structure, and as you see, I'm always commenting my source code really well. Can you see that it's green? I think so. It says default modules.
So Carl can see that.
So can't see that. No, okay.
No, actually, I cannot.
You can't. But I'm going to tell you this is a comment. And if you know XML, you know what an XML comment looks like, though it starts with these obscure character combinations. Well, and all my dashboards, they start with this. That pretty large section of displays the menu here on top, displays the selection stuff up there. It displays this, where you can say, I want this dashboard scheduled, delivered to me via as a PDF once a day, let's say once a week. And it displays this time range picker, which I have on each dashboard. So that's the same for each time. When you create the dashboard for yourself, you just take that and copy it and just change the header. So, and the actual work that you need to do when you create your own dashboard is in here. That's the search. Of course, you need to define which data you want to see in your dashboard, and that's what you do with the Splunk search, which I showed you a really, really simple search at the beginning of this presentation. You're going to refine that, of course, for a real dashboard, and once you have refined it in such a way that the data is meaningful to you and that you want to see it, and present it that way, you can create that dashboard out of it. So it's not magic. If you take an existing dashboard as a template, it should be very, very doable. So, okay, I guess my time is up. Please ask me later on if you have any further questions. And yes?
How much is it? How do we buy it?
How do you buy it? You can buy it through a web shop.
T-shirt.
You can also buy it in t-shirts if you want to. No. And the price starts at roughly 375 users per terminal server. It obviously gets cheaper to buy licenses for more than one terminal server, or at your 19 for clients.
Okay.